Let me just start by explaining what I kind of mean by mixture of models. So this is kind of based on the wisdom of the crowd principle, right? So basically what we're going to do is we're going to give all the models we are going to use the same problem, and then we're going to use different architectures to kind of extract the answers. So I created 3 different architectures for this video. So we kind of have the king, we have the duopoly, and we have the democracy. So let me show you all of these different architectures, then you kind of get a better understanding of what I mean by this. So if we take a look at the architecture 1, that is kind of the king. So here we have, let's say 1, 2, 3, 4, we can have up to as many LLMs that we want. And I've called these peasants. So we can have Llama 8b, Claude 3 Haiku, and any kind of LLM we want. And we're going to ask them the same user query, right? And we're going to compute that answer, and we're kind of collecting all of these answers. And then we're going to use these answers from the peasants as context and combine that with the user query. And then kind of the king comes into play, right? And the king here is going to be GPT-4 Turbo. And it's going to look at all the context that is kind of answered from this hive mind here. And it's going to combine that with the user query, the original problem. And then it's going to kind of use that to compute and kind of come up with a final response to the user. So this is more like... okay, so you peasants go collect some research on this topic, then I'm gonna decide what's the best answer, right? So this is kind of the first architecture we're gonna test, and we have the second one. So this is the duopoly. The setup is kind of the same. We have some advisors, in this case basically the same models as before. They're gonna go and collect the answers for context. We have the same user query, but here we have a different kind of architecture. So we have what I call co-founders. So we have GPT-4 Turbo and we have Claude 3 Opus. So you can see I'm kind of using these powerful models at the end here, right? So I found that was pretty good. And here we kind of set this up. So here Claude 3 Opus and GPT-4 are going to discuss what the findings are from the advisors, and then gonna try to come to an agreement and what is gonna be like the best answer to this problem. So they're gonna discuss among themselves. So I found a pretty cool way to do that. So yeah, very interesting. I kind of think this is my favorite architecture. We will see. And the final one is the democracy. So here we have a bit of a different approach. So you can see here every single model has the same kind of weight. So here we have 5 different models, right? We're gonna give them the same problem. We're gonna feed all the answers into like a box. And then the LLMs come back again. They're gonna look at the answer box and they're gonna vote for the answer they like best from this box, right? So basically, yeah, an election, a democracy. And when we have all the votes, we're gonna have a teller. Yeah, we can use GPT-4 for that. And it's gonna count all the votes and it's gonna pick the solution that has the most votes. That is going to be our final answer. So kind of the flaw about this architecture I found out is, let's say you have 10 kids and 1 adult, and if all the kids have the same weight, the answers can be really bad. But we're going to try it out and see how it works. So basically that is what I meant by mixture of models. There's more architecture we can explore in other videos. But now I think we're just going to start with the first one, and I'm going to show you how I set this up and do some testing. Okay, so let's start by looking at our code here. So remember, this is the king architecture. So you can see we have our Llama 70B function. So this is going to be from Grok. We have our Ullama CPP, as I call it, function that is going to take in different models from Ullama. So we can kind of set that in kind of a list. I'm going to show you that. We have Claude 3. So we're going to use Sonnet for this run. We have OpenAI, GPT-4 Turbo. Remember that is our king, right? And here we kind of pass in a system message as an argument too. I'm going to show you that. But other than that, basically pretty easy setup. I created an HTML response. So instead of getting the answer in the terminal, we can get the answer in like an HTML file. I'm going to show you that. And here is kind of our main function, or the king function. So let's start by looking at the system message. So remember, this is going to be for OpenAI's GPT-4 Turbo. So you are a wise and knowledgeable coder and problem solver king who provides thoughtful answers to questions. You have 6 advisors. I actually think it's more like 10 advisors, but that's fine, who offer insights to assist you. Consider a perspective and advice, but ultimately provide your own well-reasoned response to the problem based on all context and advice. If you find their input helpful, feel free to acknowledge their contributions in your answer. That is our system message. Here you can see we feed in all the models from Ollama, and very easy setup. You can just put in whatever models you want here. So you can see we are using some Wizard, Llama 3, Mistral, Qwen 14b, Phi 3, Gemma, CodeQueen, OpenChat, CodeQueen, OpenChat, and Magic Coder. And you can add as much models as you want in this setup, because we are running this in a for loop, right? And we are feeding in models for each user message, and we are kind of compiling this into peasant answers. And for the ones that are not Ollama, we are feeding this kind of in a separate run here. But we're gonna feed this into the peasant answers too. Alright, so this works pretty good, and we are using some kind of cool UI that I'm gonna show you. So it's a bit more interactive. And when we come to kind of the king prompt, you can see here we're gonna feed in the peasant's advice. We just take the peasant's answer and feed it in here. We're gonna feed in the problem again, that is gonna be the user message. And then we're just gonna follow up with use the insights from the advisor to create a step-by-step plan to solve the given problem. And to solve the problem your way, also include footnotes to the best advisor contributions. So that is basically our prompt. And of course we're gonna use OpenAI, feed in our king prompt, system message, and we're gonna return the king answer. Pretty easy setup here at the end. I have the option to run this twice, but I don't think we're gonna do that now. So let me just do it like this, right? And that is basically it. So we're gonna start with the marble problem. So this was given to me by someone on Discord, so I'm gonna just quickly show you that. Okay, so this problem was given to me by RT, so over at our community Discord. If you want to become a member, just follow the link in the description and you will get access. So he wrote this. So he wants this problem to be solved. So let's just copy that and bring it over here to our marble problem. So now for a hard logic reasoning problem, assume the laws of physics on the earth, a small marble is put into a normal cup. Cup is placed upside down on the table. Someone takes the cup without changing its orientation and puts it inside the microwave. Where is the marble now? We can do like this. So this is the first problem we're gonna try to solve. We have a second problem. So this is just something I wrote down. John have a sister named Lena. When John was 6 years old, Lena was half John's age. John is now 30. How old is Lena? Okay. The final problem is a lead code problem. So I thought that was good, bringing some coding, because we have a lot of coding models here, right? And this is a problem from context 393. So this should not be in the training data. And I chose a hard problem this time. So I copied that, pasted it in here, lead code problem, and write Python code to solve the lead code problem, use Python 3 syntax. So we're gonna try to solve that too using this architecture. And the final problem I have is just pretty simple. Write 10 sentences that ends with the word apples. Okay, so we're also gonna try that in some cases, I think. So yeah, that's basically the setup. Now let's start with our marble problem. Okay, so let's run this now. So first, I kind of just want to show you the UI I created for this. So you can see consulting wizard LM2, and we have 0 of 9 different tasks, right? So this is kind of to make it more interesting when we're actually running this, right? So consulting llama 38b, and we get this percentage of how far we are along on this arc, right? So consulting Mistral 7b. So this is just more for UX. It's more a bit more interactive. So let's just let this run now, and let's take a look at if we can solve our marble problem. Okay, so here you can see the pop-up. So now we have the response from AI advisors. That's pretty cool, right? And you can see here, we kind of get a step-by-step solution as we wanted. We have the initial setup, the cup placement, the cup movement, analysis of marble's position, conclusion, and you can see final answer. The marble is not inside the microwave or the cup. When the microwave is turned on, it remains outside on the table or floor where the cup was initially placed and picked up. Perfect. So that is great. That is the correct answer. So you can see advisors' contributions. Mistral 7b and Claude 3 provided crucial insights into the role of gravity and lack of containment when the cup is lifted, which supports the conclusion that the marble falls out and the cup is picked up. And Llama 38b also correctly identifies as the marble will be already fallen out. So yeah, just perfect. That is exactly what I was looking for, right? I want some good advisor's contribution. I want GPT-4 to look at all of this and kind of come to a conclusion that the marble must have fallen out before we put it into the microwave. Perfect, 10 out of 10 for that one. Now let's do our second problem. And that is gonna be this problem, right? So this is just yeah, simple logic problem here. I'm just gonna run quickly through all of the problems, and then we're gonna do kind of a roundup at the end. And we're also gonna check the lead code problem. So let me just run through all of this and see where we end up, right? Okay, so now we have solved all problems. Just a small tiny detail here. So what's pretty cool about this UI is you can see how long each of these tasks took. The lead code problem took almost 3 minutes. The other one was around 1 minute, right? But now let's take a look at the answers. So remember our first or the other problem was the John is now 30 years old. How old is Lena? Of course, since when John was 6 or Lena was half John's age. She was 3, right? But when John is 30, the answer is not half her age. She's now 27, right? Because it's just 3 years between them. So let's look what we got from the answer here. So you can see Lena is currently 27 years old. Yep, perfect. Contribution, wizards to LM advice was clear. Llama 8b and OpenChat, good details. So yeah, perfect, that was correct. Then we have our lead code problem, right? Pretty hard problem, to be honest. And if we take a look at the answer we got here, so this was pretty big. And this is our answer. So let's just copy this. Let's take a look at the footnotes. So the solution suggested by Llama 70b effectively calculates the sum considering all possible sub-array partitions. The recursive and bitwise operation are inspired by the initial advice from Wizard LM2, which provided a foundational understanding of handling bitwise and operations in subarrays. So let's test this now. So let's head over to our lead code here and let's put it in and run it. So remember, this is a hard problem, right? Okay. Oh wow, that was accepted. So case 1, 2 and 3 accepted. Wow, I didn't kind of expect that. But I know we are running GPT-4, so it's pretty good at coding. But yeah, very happy with this. So we solved a hard lead code problem, so very good. And the final sentence problem, write 10 sentences that ends with the word apples, right? Okay. And here you can see, let me see here. So let's create 10 sentences. Apples, 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 youth. So that was not completed. So we missed one, we got 9 out of 10, so that was a failure. But other than that, I think every single problem was solved except the last one. So yeah, very happy with kind of the first architecture here. And I think we're just gonna move on now to the second architecture. And that was of course the Duopoly. So here we're gonna gather some advisors insight. We're gonna discuss over the answer between GPT-4 Turbo and Claude 3 Opus, right? And we're gonna hopefully come to an agreement on what is the best answer. Let's take a quick look at the code before we speed through all the problems again and check it if the answers is good. So in the code, the setup is basically exactly the same. We have the same models, but we have some different system messages. So we have a special message for the OpenAI co-founder and the Claude 3 co-founder. So let's just read through one of those. So you're a wise and knowledgeable OpenAI coder and problem solver expert. And discuss and push back at Claude 3 Oracle. Challenge his suggestions and evaluate the best solution based on the context from other advisors to solve the problem. And then we're going to feed in a problem again. So here we want the two models to discuss and kind of push back at each other's. And this system message is just to pick out from the conversation and find the solution. So you're an expert looking at conversation between two oracles, extracting the best answer to a problem from the conversation, right? And that is basically it. We have our models, right? We have kind of the same. Here we have, if you take a look here, we kind of want to set a conversation history in an empty list. And we want to append each answer from what Oracle Claude said and what Oracle OpenAI said. We're going to run this 6 times. You can adjust the number of turns. It says 5, but it's supposed to be 6. Okay. And they're just going to go back and forward with kind of this Oracle prompt to start things off. And here we're going to feed in the insights from all the peasants or advisors. And let's discuss and find a solution to the problem while challenging and taking the advisor's insights into consideration. Solve the problem. And we feed in the problem again. And then they're going to discuss and hopefully come to a good answer. And the final response is going to be running GPT-4 over, summarize the conversation and conclude with a final answer to the problem. And we're going to feed in the full conversation between the oracles or the agents. And we're going to use system message 5, right, that we just looked at. And we're just going to return that in our HTML format. And yeah, that is basically it. So let's start with the marble problem, right, again. And let's just run through all problems and look at all solutions and see if we can match the first architecture. Okay, so I just wanted to take you back to kind of show you how this discussion between the oracles works, right? So you can see Oracle Claude 3 said, thank you for interesting problems, and it kind of solves, takes all the advice into consideration here. And it's just going to ask like, let me know if you have other questions, insights to add, Oracle OpenAI. And you can see OpenAI Oracle responded. Thank you, Oracle Claude 3, for the detailed analysis. I'd like to challenge the assumption made by Llama 3.8b and supported by your regarding marble falling out. And you can see they're going to go back and forward here and discuss and try to come up with a good answer, right? So yeah, that is kind of how this works. So we're just going to let this run and we're going to take a look at kind of all of the problems in one, right? So yeah, see you back when all of the problems are been answered. Okay, so that was all the problems done. Let's take a look here now. So you can see this was the first question. So this was the marble problem. After considering physical interactions possibility, leans towards the marble likely remaining inside the cup when placed in the microwave. So that is wrong. So actually here we got the wrong answer. You can see interesting here, Llama 8b, Llama 3.8b and Mistral 7b. Suggests that when the cup was initially inverted to a table, the marble rolled out on the table. But here, OpenAI and Oracle Claude 3 kind of discussed their way out of the correct solution. So I thought that was interesting. So no, that was wrong. The second problem was the simple logic problem. Conclusion, the correct answer is that Lena is currently 27 years old. Yeah, that's correct. Age difference of 3 years. So that was good at least. Here on the lead code problem, we didn't actually get kind of the final solution here in the conclusion. But if we go here into the chat log, I think I found a solution here. So let me just, was it here, I think. So let's try to copy this, right? And let's test it. Okay, so let's paste it in here and let's run it. So it looks pretty much the same as the last one. So yeah, we got all cases accepted. So that was correct. Okay, so that was good. And the final one was the apples sentences. So we have apples, 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 butter, paintings. So here we got 2 wrong out of 10. So that means that the king architecture was actually better for, yeah, kind of all of the problems. So that was interesting. I kind of hope that this one was even better. But that shows, yeah. Now I think we're just gonna move to our final architecture. And that was of course the democracy. So here every single model will have the same weight. So they're just gonna vote on the answers and then we're gonna tell up the votes. And the solution with the most vote is gonna be the final answer. So let's take a quick look at how I set this up and run through the problems again before we conclude this. So this was kind of the architecture that took the most time to set up because we kind of needed to run some double loops and stuff. But basically it's pretty much the same. We have some different system messages here. So you have the authority to count all votes and find solutions to the problems that got most votes. And we have some, yeah, another system message here, and basically the setup is the same. We're gonna loop through all the models, and we're gonna answer the user message first, right? Through all the models, and through Llama 7B, Claude 3, and OpenAI. So here, every single model is gonna be in kind of the voting system, even GPT-4, right? And Claude Opus. And we're gonna collect all of the model answers in this variable here by running through all of this. And then we're gonna set off kind of a second loop of this, but this is gonna be votes. So voting options. We're gonna feed in all the answers from the models, right? Give your vote to the answer above you think will have the best chance of solving the following problem. So that is kind of the idea. And we're gonna run it through a for loop again, but this time we're gonna use this votes here, right? We're gonna feed in the model and the voting prompt. Okay, run through all of that and kind of collect all of the votes into this variable here. And then we're gonna run it through this final count. So count all the following votes, all votes. We're gonna feed in that. Print the winning solution with most votes and the number of votes. And that is kind of the democracy architecture. So yeah, had to think a bit how to set this up, but I think I solved it in the end. And yeah, I think we're just gonna do what we did. Go through every single problem we have. So that's 4 problems, and take a look at the final results. Okay, so that was complete. Now let's take a look at the results. So the first problem was the marble problem. The winning solution is with the most votes is Llama 3's 8 advice with a total of 2 votes. Okay, the marble is still in the cup. No, that's wrong. So the marble has not moved inside the cup. No, it should be on the table, so that was wrong. The winning solution, Lena is currently 27 years old. This solution received the most votes with a total of 6 votes. Okay, so that was good at least. So almost all of the models voted for 27 years old. Perfect, that's good. So you can see the system is working. I thought that was pretty cool. Okay, so let's take a look at the lead code solution now. So the winning solution with the most votes is Wizard LM2's advice. Okay, with 2 votes. And let's copy this. Okay, and let's check it against our lead code. So let's just paste it in here. Let's run it. So this was from a very small model, Wizard 2LM. Okay, so it didn't get it right. It got 1 case right. The other 2 were wrong. So that did not work. And let's take a look at the final solution. The winning solution with the most votes, Llama 3 8B. So that's getting a lot of votes. It only got 1 vote though. I don't know what happened here. Apples, apple. And yeah, that was kind of the best answer of them all. It got apples 9 times and it got 1 apple. So that was kind of the best solution of all 3 architectures. But yeah, that was every single one. I think all showed kind of different good things and some bad things. So very interesting. I just gotta say, I was very happy how this video turned out. And I was super happy that I got to put all this together. I was a bit unsure if I could do it. Like always, if you want kind of access to all of these codes, I'm gonna put every single one up on the community GitHub. So if you become a member of the channel, I will give you access to the community GitHub as well as the community Discord. And speaking of the community Discord, going forward, I'm going to highlight an open source, a GitHub repo from one of our members in every single video. So we're going to start off with Matt A here that has a GitHub project in cybersecurity. So let's take a quick look at it. I will of course leave a link in the description to this. So I just want to give it some attention. If you take a look at the repo here, as you can see, it's doing pretty good. 674 stars. That's great. 92 forks. So Attackgen is a cybersecurity incident response testing tool, leverages the power of LLMs and the comprehensive some kind of framework here. Tool generates tailored incident response scenarios based on the user selected threat, actor groups, and your organization's details. So pretty cool, right? I took a look here and it's pretty interesting. I'm no cybersecurity expert, but yeah, really like the layout here. It looks pretty cool. And looks very easy to use, to be honest. Good setup here, good UI. So that's important. You can see it can even run on local models. So it can use Ollama. So I think that's great. And yeah, I might even try it out myself. Like I said, not my expertise, cybersecurity. But if you're into that, definitely check out this repo here. I'm gonna leave a link in the description below. So yeah, pretty cool, right? So yeah, that is what I wanted to share today. Hope you found it interesting. At least I did. I haven't tried this before, so yeah, pretty cool. Very excited about it, actually. So it's gonna be interesting to see when we kind of scale up in models going forward, if this can be even better. So pretty cool idea, and I think, yeah, I think we executed it pretty good. If you have any improvements, just leave it in the comment section below. Like the video if you found it interesting. If you want to try it out for yourself, become a member of the channel. And yeah, thank you for tuning in. Have a great day, and I'll see you on Sunday.